In this tutorial, we're going to be classifying the matter in terms of the composition, and I'll have a separate tutorial where I classify the matter in terms of the state. So to begin with, let's define what matter is. Matter is going to be anything that has the mass and it occupies the space. For example, book is a matter. I can talk about any metals, maybe a copper metal is going to be a matter. Or I can talk about carbon dioxide, so CO2 is a matter. I can talk about water is a matter. I can talk about maybe air as well, even though air has a very small amount of mass, but it does have a mass and it occupies the space, so it's actually a matter. So anything you see or feel is actually going to be the matter. So when we're classifying the matter in terms of the composition, the very first question you want to ask yourself if the matter made of one type of material or the particle. So when we talk about the material or particle, we're more likely referring to if it has only one type of atoms or compounds in there. So if the answer is yes, what that means the matter is made of either only one type of atom or one type of compound, then we put that into a category of a pure substance. So that's going to be pure substance. If the answer is no, what that means the matter is made of more than one type of atoms or more than one type of compounds, then we put that into a category of a mixture. So we'll come back to the mixture in a minute, but let's go back and categorize the pure substance further. So like I said, if the matter is made of only one type of atom, then it's going to be considered an element. So an element, you have only one type of atom. So I'll say one type of atom here. So for example, we have more than 100 elements in the periodic table. So if I talk about sodium element, in sodium element, the symbol for sodium is Na. Sodium element, all you're really going to have is sodium atoms in there. Let's talk about maybe copper element. So copper the symbol is Cu if I want to write down the symbol. And copper element, all you're really going to have is copper atoms in there. Or I can talk about maybe mercury. In mercury element, all you're really going to have is mercury atoms in there. So that's actually made of only one type of atom. So that's why you put that into a category of an element from the pure substance. But what if you have more than one type of elements, more than one type of atoms rather, chemically bonded with one another? So if they are chemically bonded with one another, they actually makes a compound. Okay, so in a compound, I can have NaCl, so sodium chloride. You have one sodium atom and one chlorine atom, so there are different types of atom and they're chemically bonded with one another, so that's actually in a compound. Even and also it's a pure substance because there's only one type of compound in there. I can talk about some sugar molecules. So a sugar molecule is C6H12O6. So you got 6 carbons, 12 hydrogens, and 6 oxygens. So you have 3 different types of atoms in this particular compound, but it's still a pure because that's the only types of atoms you're going to have in there. You're not going to have anything else mixed up in there. Okay, I can talk about maybe water. Water has 2 hydrogens, 1 oxygen. I can talk about carbon dioxide. I can talk about octane, which is C8H18. So they are all examples of pure substance further categorized into the compounds. Okay, well, that's your pure substance side. Let's talk about the mixture now. So in mixture, like I said, we will have more than one type of atoms or compounds, and they're not going to be chemically bonded with one another. They will be separated from one another, unlike you have in the pure substance. So, for example, before I further categorize the mixture, let me talk about air. So, in air, what kind of chemicals or compounds or even atoms we have in there. So we got oxygen gas and air, so O2, we have N2, we got CO2, and then we have a lot of small time gases in the air. Now, we put this into a category of a mixture because we have multiple types of atoms or compounds in there, and they're not chemically bonded with one another, so that's why it's a mixture. But let me take another example, and maybe I'll take an example of a pizza. So a pizza is going to be made of a bread or the dough. We got cheese on it. We have obviously the sauce, and then let's say we have this as in a vegetarian pizza. So we got some vegetables on it. So what's the difference between the air and the pizza? They're actually both mixtures because in pizza as well you have different types of materials, like bread is obviously made of different types of chemicals, cheese is made of different types of chemicals, and bread and cheese they are not necessarily chemically bonded with one another, so it's in a mixture. But if I want to define or if I want to kind of focus the difference between the air and the pizza, in air, you have an even composition of all these gases. So what that means, all these gases are evenly mixed up where I cannot pinpoint at a particular location and tell if there is an oxygen or a nitrogen. You know all these gases are there, but you just don't know their particular location. However, in case of pizza, you actually know their particular locations, or you can also say there is an uneven distribution of all these materials in that mixture. So if you have a mixture that has an even composition of the material, then you put that into a category of a homogeneous mixture. So air is an example of homogeneous mixture. And if you have a mixture that has an uneven composition of the material, it's going to be a heterogeneous mixture. Okay, so I can go and write down for the homogeneous, that's an even composition of the material, or even distribution, I can say. And in heterogeneous, you will have uneven distribution or composition of the material in there. So obviously air in this particular case is an example of homogeneous, and pizza will be an example of the heterogeneous mixture there. Okay, so let me take a couple of examples just to kind of make sure you get the material here. So what if I have diamond? How would you classify the diamond as? Now, diamond is actually an allotrope of carbon. So another way of saying diamond is nothing but just a carbon. So since it's an allotrope of a carbon, and what carbon is actually an element. So it's going to be a pure substance, and further categorizing the pure substance, it's going to be an element. So sometimes they would ask you whether it's in a pure substance or a mixture, and sometimes they even ask you to further categorize it. So you want to make sure you are able to kind of further categorize it into the elements and the compounds. What if you have something like, let's say, maybe chicken soup? Okay, so now the chicken soup, obviously, if I break it down, what's in there, we have water in there. We're probably going to have some salt in there. Obviously, there's going to be chicken in there. And then, spell the chicken wrong here. Sorry about that. So it's going to be chicken in there. And then we'll have some flavors. And depending on what else you could have in there, let's say you have some vegetables there. Um, so in case of chicken soup, you can actually see where the chicken is, and you can probably actually see where the vegetables are. And obviously, there are going to be some materials that are evenly mixed up. For example, water and salt, they will have an even mixture. But when we look at chicken and vegetables, and as a result, an overall picture of this whole mixture, it's not going to be an even distribution of the chicken and the vegetables throughout the chicken soup. And another way of saying, you can easily see where the chicken is and where the vegetables are. So as a result, it's going to be a heterogeneous mixture. Okay, what about something like brass? Well, brass is an alloy of a copper and zinc, and it's yellow in color, but the copper and zinc, they are not chemically bonded with one another, so that's why it's going to be in a mixture, because you have two different types of atoms in there and they're not chemically bonded. And then it's since it's a mixture, but they you can't really see where the copper is and where the zinc is, because they are evenly mixed up with one another. And since they are evenly mixed up with one another, it's you're going to put that into a category of a homogeneous mixture. Okay, what about something like an iced tea? So assume you have an iced tea without the ice cubes in there, because if you have an ice cube, then someone can argue that you can actually see the ice cubes in there. But so suppose you have an iced tea without the ice cubes. So in an iced tea, we have water, we have sugar, and we probably gonna have obviously tea in there, and maybe some other flavors. Now, the thing about iced tea is the water, sugar, tea, they're all evenly mixed up. You can't really tell where the tea is or where the sugar is. It's an even distribution of different types of materials. And since it's an even distribution of all the material, it's going to be a homogeneous mixture again. I can talk about apple juice in a homogeneous mixture, orange juice, as long as it doesn't have the pulp in there, it's going to be in a mixture, homogeneous mixture as well. So that's how you actually classify your matter in terms of the composition. So just to kind of sum up everything, so first question you ask yourself if it has only one type of material. If it does, then you putting that into a category of an pure substance, which further categorize into the element if it has only one type of atom. And if you have more than one type of atom that are chemically bonded with one another, then you're putting that into a category of compounds. So I do want to mention maybe one more example of the elements here. So if you have an O2, like even though you have two oxygen atoms, since they are both the same, you still kind of put that into a category of an element, all right? So like an O2, that's oxygen gas, or even N2, that's nitrogen gas, they're still the elements. Okay, so then coming down to the mixtures, make sure you're able to identify if they have an even or an uneven distribution of the different types of material that makes up the mixture. If it's an even composition, you put in a homogeneous mixture. If it's an uneven distribution of the material, then it's a heterogeneous mixture. All right, so hopefully this video is helpful. If you have any questions, feel free to leave any message in the comment section below.